Good morning, good afternoon, good evening, everybody. So, here we are, unit number 5, and let's just dive in it because today is a little bit full of hands-on demonstration, so let's try to make the most of our 30 minutes. So, as usual, you have the handout in the folder for this unit, so Unit5 folder on OneDrive. So please do get to OneDrive and also start up Substance Alchemist so we can speed that bit up. I didn't get any email about last content, which is very good, and that it will be reflected, by the way, in the assessment results that will be sent out just after this unit. I think that everybody will be quite happy with the results, to be honest, which is good. So today the handouts are just texture, as you might have noticed if you opened the folder. Today's unit is about the difference between material created through bitmap to material and those created through image to material, which is the pièce of resistance, the most important piece in Alchemist. We present it and we learn how to use it. Actually, it is kind of a no-brainer, very easy to use, so I hope that you all will enjoy it quite well. As much as I enjoy this piece, so let's go ahead and delve into it. Now, these are the 5 textures that have been selected. Well, have been selected. I just picked them at random, as usual, across a series of public domain texture of the internet. I invite you to do the same in case you want to exercise beyond those 5 textures, and that is definitely advisable. So, as you can see, as usual, they are really random, simply because we have to simulate what happens when we deal with an actual customer. Customers do not normally are on the same book we are. They don't have the same taste as we have, so obviously we need to satisfy customers whatever they throw at us, which implies that we like it, we don't like it, doesn't really matter, we have to do our job. That's why textures are picked up completely at random. It's not important if you like it, it's important that we get the best possible result out of them. That's it. That's part of our job. So let's move on. I'm going a little bit fast because I want to give as much time as possible to the actual hand-on session, okay? But I see the chat is still clean, no messages, which makes me happy. It seems that everything is clear, crystal clear. Let's see if that stays that way. So, bitmap to material compared to image to material, I2M. Well, we talked about bitmap to material during Unit 1. It was just a presentation about the mathematically driven component that takes an image and makes a substance out of it, applying live equations, some Fourier equation, and all those nice matrix computing that tries to understand how the light is presented on a picture, so that it is possible to retrieve all the maps, normal map, height map, ambient occlusion map, and so on and so forth. Now, that was just a mathematic, nothing else. Okay. Back then, it wasn't even possible to think something more complicated, but now, with the computing power we have today, it has been possible to actually create a machine learning trained model out of tens of thousands of real-life objects that have been scanned using laser scanning and photogrammetry. We talked about photogrammetry and deep meanings during, I think, Unit 2, if memory serves. So, through those two technologies, laser scanning of 3D objects and photogrammetry, we got a huge amount of material that have been fed to a machine learning algorithm. The model have been trained to recognize those objects, because obviously each object and each photogrammetry texture has been labeled, right, so that machine learning software could understand this is a wall, this is a terrain, this is a statue, this is a car, this is a chair, this is a shoe, and so on and so forth, right? So, out of that, we have a trained model, a so-called trained model, which is a super compressed database that enable a component, a software component, to apply that learning that has been executed over time, over that and huge amount of material, applying that learning to something else. So, to be able to recognize this is a shoe, this is a car, this is a terrain, this is a wall, and so on. So this is basically the huge difference between bitmap to material, the legacy component, and image to material. Image to material is driven by a trained machine learning model which enables it to understand exactly what it is. It's not just applying straight mathematics, one size fits all to everything. But it is something that recognizes what it is and applies a specific set of equations, taking into consideration the meaning of the texture, the meaning of the picture that has been fed to the component, which is super important. And we'll see that the result, it's crazy, really. So, let's try just to skip through this, because in reality I was going on, and this is exactly basically going ahead of the slides. So yes, this is what I was saying a moment ago. All those maps are driven by equations that are driven through artificial intelligence powered algorithms. Okay, so objects, shapes, material, light sources, shadows, everything has been taken into account, everything that was labeled properly during the analysis to train the model to enable then the component to actually do its job. Okay, I think that we do have an idea, right, of what we are talking about. Chat is still empty, so either I'm overwhelming you guys, or I've been very clear, which is good. I hope the second. So let's move to the hands-on session at this point. We still have a few minutes before the break. The break will be the usual 5 to 10 minutes, and then we keep going with the hands-on session. And at the end of the unit, as usual, I will present you with the assignment, which I suppose at this point everybody can imagine what that is. Okay, so let's delve into it. This is the usual interface, the Substance Alchemist, a brand new project just created. Here I have a plan. The plane that you see here is the best mesh for the first texture. At least this is what I believe. Let's do this. So, as usual, let's start with the first one. I take this and I drop it in here, as we have seen multiple times by now. So, at this point, we all know Alchemist stops and asks me, okay, what do you want to do with this, right? You dropped me a texture. Is that for image to material? Is this a multi-angle? Is this just a texture? Or do you want me to use this as a straight bitmap? Well, we have seen the texture import and the bitmap import, and it is now the time to click OK, just to click OK, accepting the image to material, because this is what we want to see now. And now, as you can see, image to material component has been added. He was just thinking for a little bit, and then Here we go. Real fast. But this almost doesn't need any work. Look at the result. This is kind of crazy, guys, right? So we have this material, this substance that basically doesn't really need anything else, right? If we look at the parameters here, the usual ones, we have an amplitude for the displacement of 0.09. Let's bring that up a little bit, just a little bit. Here we go, just to improve the surface. But to be honest, there isn't much that we can do here. Let's click on image to material to see the parameters. And as you can see, parameters are really simple for this component. That because all the mathematics, it's already almost fully satisfied through the analysis of the image. Okay, so there isn't really a lot that we need to tweak. Well, we do have the ability to equalize the geometry, and this allows us to repair damages in tessellation in case tessellation is damaging the plane and we don't want to push it too much. You remember about tessellation, right? And then we have the inversion of height and the inversion of roughness. These are just safeguards, because it might be that for some reason the height map and the roughness has been understood the other way around by the component. If that is the case, we can invert it. As you can see, if I push the inversion, all the system gets kind of crazy because it was not mistaken. It was okay. So, but as you can see, it basically inverts everything, right? What was depth becomes height, and what was height becomes depth. But we don't need that. There was no mistake. Everything was correctly understood. And to be honest, ever since this component has been published, I haven't had any need to use invert normal or invert roughness. Sure, we can add some software variation. We can improve adding more variations to the roughness so that we have a little bit of reflectivity that is added in some of the points, and that can be maybe even more evident if we create a new project and we use I don't know, let's bring in the rocks. Let's think about it. It's thinking. Hey, here we are. We have the rocks. And here, you see there is some shyness that has been properly understood by the system, you see. Here is more evident than before, and this exactly before, because the system understood that the roughness and the shyness on the surface on a wall, or that wall of pavement, or whatever that previous texture was kind of flat, while in this kind of rock formation we do have some shyness, and it has been properly understood, you can see, right? So this is the result of an intelligent component that uses real life objects learned through machine learning. Now, those elements that you see there, which seems to be holes, those are not really holes, those are just elements with too much shadowing. Those can be corrected both moving on the displacement amplitude, like that, or working on the lighting and removing a little bit of the occlusion, the ambient occlusion, which sometimes is too strong. But anyway, those are very little, very small correction that needs to be done, right? The result out of the box is really satisfying. Okay, guys, we are 15 minutes in, so I think that it's time to think to our break. After the break, we are going to see the other texture, and then we are going to have a real quick introduction of what I expect from you as output to be assessed out of the content of this session. Okay, thank you very much, guys. I'll see you in, let's say, 10 minutes. Okay, bye, guys.